The elimination method is as follows. If I want to solve a system using elimination, I'm going to do the following. I'm either going to add or subtract the equations together. So one of the variables is eliminated. This method is really nice. It's really useful for systems where like substitution doesn't seem like it's going to work. Especially for systems where it doesn't look like graphing is going to be very, very easy and or worthwhile. For example, our first problem here. Notice that these two equations look like things I would never ever want to try to graph. Maybe not ever, but you guys probably would not choose to graph these. Also, there's not really an easy variable to get by itself. Like I'd have to do a bunch of rearranging. I'd do some division. I'd probably introduce some fractions. That doesn't seem to be like a good idea. If I try this elimination method, though, look what happens. If I chose to, how about if I added these two equations together? What's going to happen?
You get one big equation.
I'm going to get one big equation. But more importantly, looking at the values that are in this equation, what's going to happen when I add the like terms together? Lily?
3, and I have to cancel out.
3y plus negative 3y is 0. It's nothing. They will eliminate each other. If I'm in a situation where I have two equations where one of the variables has coefficients that, I'm going to use a fancy term here, called matching up. If they match up so that if I add them together, they are going to cancel each other out, they're going to eliminate each other, that's good. That's a sign that I want to use the elimination method. So I'm going to go through, and I'm going to simply just add these two things together. I'm going to add all the like terms. So I'm going to add 4x and negative 2x. What do I get? What do I get when I add minus 3y and positive 3y?
0.
And what do I get when I add 5 and negative 7?
Negative 2.
By combining those two together by addition, I get this new equation. 2x plus 0 equals negative 2. Or, simplifying this just a little bit, 2x is negative 2. What's x equal?
Negative
2. Negative 1.
Wow, look at that. It took us all of 1.5 steps to get to what x is. As opposed to rearranging, substituting, distributing, combining like terms, taking up a whole page. We end up with what x is in one step, essentially. 2 steps, maybe. A lot less work. I'm going to jot down what step 2 was here, because we just did it. Step 1 was add or subtract the variables so that one of them is eliminated. Step 2, solve the new equation for the remaining variable. So solve for x, and that's what we just did. We got x by itself. Boy. We're solving a system of equations. When you're solving a system of equations, we're figuring out where the two equations cross, where they intersect. So we need to find the point of that intersection. We only know x, which means I need to know the other part of that point, the y. What do you think we're going to do to find y? Same darn thing you did for substitution. The last step is plug your answer in. Plug your answer into one of the original equations. to find the other variables. So to finish solving this, I'm going to take my answer for x. I'm going to go back to the original equations here, and I'm going to pick whatever one you like. I'm going to go with the first one because it's the first one. It doesn't seem to be any significantly harder or easier than the other. 4 times negative 1. Oops. Minus 3 times y equals 5.
Answers.
Negative 4 minus 3y is 5. And 4. Negative 3y is 9. Y is negative 3. So therefore, these two lines, if you were to graph them, cross at the point negative 1, negative 3.
What happens if the values don't cancel out?
Ooh, what happens if they don't cancel out? That's we're gonna figure out how to adjust this method tomorrow to make them what we can do to rearrange them so they do match up.
What's step 3?
Say that again.
What's step 3?
Step 3 was plug your answer back in to get the other variable. Okay. You want to do the second one together, or you think you can do this one by yourself?
God, it's still good to be
Yes. This one together, I'm going to do a couple on the back side, and then we'll call it good. Let's see. This looks like a prime candidate for elimination because it looks as though the x's in this case are matched up. I have a negative 5 and a 5, and if I add those things together, they're going to eliminate to nothing. Well, what's negative 5 plus 5? 0. That's good. We got rid of the x's. What's negative 6y plus 2y's?
Negative 4y.
And what's 8 plus 4? 12. Or just get rid of that useless 0. We get negative 4y is 12. What's y?
Negative 3.
Y is negative 3.
Good.
Once you know what one of them is, go back to the top and plug in to figure out what the second variable is. Which equation in this case do you think we want to use?
Top.
Top or bottom? Which one is going to be easier to find x?
I like top.
Let me attach the question then y. Which one and why? Brent and why? Which one and why?
It's easier.
It looks easier. What looks easier about this one than the top one?
I'm good with negatives.
You're good with negatives, so you want to see lots of negatives in yours.
Yeah.
Courtney?
The second one, because you don't have to deal with the kind of negatives.
There's no negatives. I see another reason why I might go with this one over the top.
Wow.
Yeah, and there's smaller numbers too. There's smaller numbers in the bottom one, and there's no negatives.
I'm a big number person.
So if you're a big numbers person and you love negatives, then sure, whatever one you like better. I like smaller numbers and I like positives. So I'm gonna go with the second one. And I'm gonna say 5x plus 2 times negative 3 is 4. I know y. I'll plug y in. Find x. 5x minus 6 is 4. 5x is 10. X is 2. 2 times negative 3 is negative 6. Add 6 to both sides. Divide by 5. So then what point do these two lines cross at?
Oh, look, we have the same thing, right? The top one.
And Brennan did the top one. He got the same answer, which shows that hopefully it wasn't lying to you, that you actually do get the same answer no matter which one you pick. On the back side, there are 4 examples. I'm going to pick 2 of them very deliberately. The first one I want to choose to do is the upper right-hand box. I'm going to do with you. And then we're going to talk about the lower left-hand box.
Whoa, it doesn't cancel out.
Okay.
They're too positive.
In the upper right-hand box, Jack just noticed that I have 7x minus 2y equals 5, and I have 7x minus 3y equals 4. If I add them together, the 7s won't cancel each other out. So Lily, what do I want to try? I'm going to try subtracting them. Now, you can go about doing this two ways. Since I want to subtract, you could go and just subtract term by term. So what's 7 minus 7x? 0. What's negative 2y minus negative 3y?
Negative 5.
It is not negative 5y.
Oh, it would be 1.
We have negative 2 minus negative 3. Negative 2 plus negative 3 is negative 5. Negative 2 minus negative 3
Oh, idea.
plus a negative. Okay, notice how that can get tricky. Why am I choosing to do subtraction? Because I did positive 7 and positive 7. If these are the same sign and I add them, I'm going to get a bigger number. I'm not going to eliminate them. The goal of this elimination method is to get rid of one of the two variables. So I need to subtract here. 7 minus 7 gets me 0. Now, as you notice, it can get tricky with all these minus signs floating around. Well, we've seen in the past that if you took two numbers like x minus 1, that's the same as x plus negative 1. Right? We do plus and negative. So if I want to change this to a plus, I'm going to flip all of the signs in here. So if I need to subtract, instead of subtracting, I could do plus, and then I'm going to go through and flip all of the signs in this equation. What you're basically doing is multiplying through by negative 1. Okay? It's when the values that you're trying to eliminate are the same, you can either subtract, or it's the same as subtracting is adding a negative. So add the opposite of everything you see. Flip every sign if you wanted to subtract. Exactly. Just like we saw before, if one's positive and one's negative, that's fine. Adding those will just eliminate them. We don't need to subtract there. We're doing it because of the positive and negative. If they're the same sign, we need to figure out how to subtract everything. And subtracting all is the same as adding the negative of all of them. So I'm going to flip every sign whenever I would need to subtract. Okay? Doing that is going to give us the exact same result without having to do a ton of extra crazy thinking. So if I decide to add the negatives of all of these, then I get what? 7 plus negative 7, and that's still 0. Negative 2 plus 3y is still 1y. And 5 plus negative 4 is still 1. I get the same answer. But this way I didn't have to worry about there's a minus in front and minus, minus, and minus, and it's a lot of stuff going on. If you're thinking, hey, I need to subtract, instead of subtracting, add the negatives of everything. Flip all the signs. Either way, we still get this elimination. Y is 1. Once y is 1, how do we find x? I have to ask this question 30 times over the last 2 days. Plug it back in. Which one looks like a candidate to plug into?
The one that looks easier.
I like this top one, I think. So I didn't have to mess with it. 7x minus 2 times 1 is 5. 1 and 1. Don't pack up yet, please. I want to at least introduce you to the last one before I get you homework. The last problem, what's different about this last thing than all the other ones we've done? What's different about this setup than everything else we've done so far?
Oh, they're
Courtney?
mixing around.
The variables aren't
Like that.
The variables aren't on the same side of the second equation here. Always start, if you're doing this elimination method, always start by rewriting your equation so the variables are on the same side.